Hello. Today I am going to do a little review video. Hopefully you've seen this stuff, but if you haven't, I'm going to make sure you do on simplifying square roots. So I know that a lot of you guys have seen those Vans logos. This is actually the square root of answer, which is hilarious to me. Alright, but that doesn't really matter. Anyways, these are square roots. Square roots. We're going to be finding pairs, which I'll talk about in a second. But for now, what you got to know is what they're telling you that they're not telling you. So whenever they write a root with no number, the number that is here is 2. This represents the power of the root, or like if we turned it into a fractional root, it would be the bottom, the denominator of the power. Anyways, what does it mean as far as what you need to know about it is that when we have a number here, when we want to simplify it, we are going to take out multiples. And for every pair, so for every group of 2, and this is important because if it's not a square root, it would matter, then we're going to take out, so we're going to take out our groups. And the things that are not groups, we're going to leave inside. These are going to be our leftovers. And I know that's a lot of words, but hopefully that makes it more simple when we just do a couple examples. So a basic example here is like if we had the square root of 50, we're going to find multiples of 50. So that would be like 5 and 10, or 2 and 25. And then 5, once you have a prime number, a number that has only a multiple of 1 in itself, you can stop. And it's the end of like the tree branch. To take about the 10 only one way with a 2 and a 5. And then I can't multiply or find any more multiples of those branches. So from here, I'm going to find my pairs. So what pairs do I have here? I have one pair of 5s. So for every pair, we get 1 on the outside. So I'm going to get 1 5 on the outside. Oh yeah. 1 5 on the outside. And what's left over, what does not have a pair, is this 2. So to simplify it down, it would become 5 root 2. So this was my pair, and this was my leftover. This is the most simple example because we have one pair and we have one leftover. And it doesn't address what happens when you have more than one pair or more than one leftover. But from a concept standpoint, this is what we're going to do. We're going to take apart multiples. For every pair, we're going to take it out of the root, and everything that does not have a pair, we're going to leave it inside. Because that pair represents that squared number, so it does not have to be represented in an unsimplified root. Okay, so let's do a couple more examples. And let me clear out the space. So what am I talking about? We might see something like, let's do square root of 72. So if I have square root of 72, I'm going to take it apart. I could do it with 2 and 36, or 4 and 18, or 8 and 9. 8 and 9 seem most common, so I'm going to take those out. Could I take anything out of an 8? Yeah, I could get a 4 and a 2, and from that 4 I could get more 2s. 9, I could get a 3 and a 3. So those are my primes. Can't multiply or take more multiples out of those. So what pairs do I have? Well, I've got this one pair of 2s. I don't have this other. This is a third 2, so I can't throw that into a pair. Maybe if I had another 2, I could circle it and make a second pair, like this pair of 3s. So now instead of just having one pair of 5s and a leftover 2, I've got a pair of 3s and a pair of 2s and a leftover 2 still. So just like in our last example, that 2's, yeah, it's going to stay on the inside. It's leftover. But what are we going to do with this 3 and the 2? We're not going to make a 32. We're not going to add them. We are going to multiply them together. So this is 1 for each pair. Pairs. And then we're going to simplify that and multiply them together and get 6 root 2. I think this is actually one of the examples, or no, I'm going to change that problem now. Okay. All right. So let's go over what happens if you have multiple, let's see, something that has multiple things on the, okay, what if we have like a root 75? Wait, does that fulfill what I need? No, it does not. Okay, I want something that has multiple leftovers now. So let's do, I don't know, 120. So if I take apart the square root of 120, 4 and 30, or 2 and 60, or 10 and 12, no matter what, you'll get the same. So with the branches, as long as you do your branches correct, you should be fine. A 2 and a 15. And then I've got a 3 and a 5 from here. And these are all my ends. So I can't take any more multiples out. Do I have any pairs? Yes, I have one pair. It's a 2. But I've got 3 leftovers now. These are all leftovers. So what's going to happen, remember we got our pairs on our outside and our leftovers are inside. And just like we did with our pairs here when we multiplied, we're going to do the same thing if we have multiple leftovers. We have a 2 and a 3 and a 5 left over. And I'm just going to multiply those together and get a 2 root 30. And that is my simplified root. So you might have, you know, one pair and one leftover. You might have multiple pairs, 2 or 3 or 4 pairs, and have to multiply them on the outside. And you might have more than one leftover and have to multiply them on the inside. This is a review of how to simplify square roots and the situations you'll see with it.